Good afternoon, students. Our next topic is asynchronous data transfer. We know that in the digital systems, the internal operations are controlled by clock pulses. So we have a common clock pulse generator. It generates clock pulses, and based on the clock pulse, the devices can perform different actions. And suppose in our example, so we have two units, CPU and IO interface. Okay, so this CPU and IO interface have their own registers. Now the register in the CPU want to transfer some data to the IO interface, the register in the IO interface. So for that, to initiate that particular operation, it requires clock pulse. Now, the CPU registers and IO interface use a common clock generator, clock pulses. Then we can say that the data transfer between the CPU registers and IO interface registers is synchronous data transfer. Now, another data transfer, that is asynchronous data transfer. So that is, suppose internal timing. So means here the CPU has its own clock generator, the IO interface has its own clock generator. Okay, so it means they have different clock signals. Based on the clock signals, that is internal timing, okay, they will perform their actions. So the data transfer from CPU to IO interface or IO interface to CPU based on their individual clock pulses, or means the internal timing in each unit is independent. They have their own private clock signals for their registers. Okay, so such type of data transfer is called as asynchronous data transfer. Next, asynchronous data transfer. So between these two independent units requires some control signals. Okay, to communicate in the units. Okay, or data transfer between these two units, they need control units, independent control units. Okay, so means that CPU has some control unit signals, the IO interface has some control signals. Here we have two types of control signals called as strobe and handshaking. First, we will see what is the strobe signal. Strobe control signal. This control signal indicates that the time at which data is being transmitted. So means at what time the data is transmitted from the source unit to destination unit. Now observe this figure. Okay, see here we have the source unit and here we have the destination unit. So through this data bus, the data is transferred from the source unit to the destination unit. When? So that when is initiated or specified by this strobe signal. Understand? Initiated by this particular strobe signal. Okay, so based on this strobe signal, the data is transferred from the source unit to the destination unit. Here we have the two types of strobes. One is called as source initiated strobe. Source initiated strobe. So already we discussed what it is, the asynchronous data transfer. Asynchronous data transfer means the two units have their own clock signals, their own control signals. Okay, now who initiated the strobe signal? Source or destination? So based on that, so there we have two different timings. Now observe this one in the first play, in the first one. See, here this is the data signal. Okay, so data is transferred here. Okay, so now from this point data is transferred. Okay, but when the data will be transferred? So that is based on this strobe. See, here data is highlighted. See, here data is highlighted. Okay. Now, so now from this point the strobe is started. So when the strobe is highlighted, so at this point the data is validated and data is transferred to the destination unit. Okay, data is transferred to the destination unit. Understand? Data is transferred to the destination unit. When the control is, the strobe is, okay, inactivated, then so the data transfer is forward. Means the data transfer is completed. Understand? So first data is initiated and then so it means the transfer of data is started here. But so it is valid the data and transfer to the destination after the strobe is activated. Okay, who initiated this strobe? Source only. Okay, so source only initiated the strobe when the source is itself, okay, itself known that I am ready to send data. So then the strobe is activated and data is transferred. Understand? That is the source initiated. Now come to the destination initiated. Okay, the next one is the destination initiated strobe. Here also same thing, but here observe this. So here the first action will be performed by the destination unit. Why means, so first of all we have to check. So we have to check that particular data transfer. If the destination is ready to receive the data or not. Okay, so that is has to given by the destination unit only. That's why here the first destination is activated the strobe. First the destination is activated the strobe. Say here. After the destination is activated the strobe. Okay, so then the source unit is ready to transfer the data. See, here data is transferred. Okay, so after receiving the entire data from the source, okay, the destination unit is deactivate the strobe signal. After strobe signal is deactivated, okay, so then the data is transfer is completed. Okay, so in this way, so here the strobe control signal is what? Okay, so there are two types of the strobe signals: source initiated strobe and destination initiated strobe. So here we have some disadvantages about this strobe signal, control signal, that is, so destination data. So means suppose if we take destination initiated strobe, so means that the destination where the data is transferred. Okay, so in the advance we have to know to the information regarding destination. So but that is not possible in all the situations. Okay, so we have another method called as handshake method. We have another method called as the handshake method. Okay, understand? So strobe, the second control signal is handshaking control signal. So now here in the handshaking, So here there is an agreement between the two independent units. So here we have the some third step. Okay. Here also we have two types of the handshake control signals. One is source initiated handshake and another one is the destination initiated handshake. Now observe this one. So here we have the source unit. Okay. And here we have the destination unit. And here data bus. So through data bus, data is transferred from the source to destination. And here we have another two control signals. So observe here, one is called as data valid. One is called as the data valid. Okay. So another one is data accepted. Now observe the points also here. Data valid from source to destination. Data accepted is from destination to the source. Now observe here, what is the first point? The first point is source is sending some data to the destination through data bus. So here, okay. So through data bus, source is ready to send some data to the data bus. So at that time, the source is also initiated a control signal called as handshaking. That handshake control signal is activated the data transfer. So means it said that data is ready to send. So now when the handshake control signal is activated, so now the data is transferred to the destination. See here it is in the high. Okay. Similarly here the data handshake is also in the high. So when the data handshake is disabled, okay, so means the entire data is transferred to the destination. See, here data is transferred to the destination, over. But here, what is the third step means, after receiving the entire data from the source, the destination has to acknowledge to the source that it received the entire data. Understand? After receiving the data, the destination has to give some acknowledgement to the source. Okay. So for that, it is activate a signal called as data accepted. Okay. Activate the signal called as the data accepted. See here, this data accepted is activate after, okay, data is transferred. Okay, when it comes to the ending point, so that time, so here the data accepted signal is activated. So means destination is sending information to the source. So similarly, here we have the destination initiated handshake. Here observe we have the same thing. Data bus, data valid, ready for data. Okay, so here the signal is changed. Ready for data. Okay, so now what is the first step? Place the data on the data bus. The first step is we are placing the data on the data bus. And after placing the data on the data bus, so enable the data valid. Enable the data valid. So now what the destination has to do before receiving the data. Here what the destination did, after receiving the entire data, it gives acknowledgement to the source. But here in this example, in this destination initiated handshake, the destination unit, okay, before receiving the data, it gives acknowledgement to the source that it is ready to receive the data. The destination is ready to receive the data. Okay, so when the so when it says that, so that is then, so we have to disable the data valid. Okay, so suppose if it is not ready, okay, disable the data valid. Okay, so disable the data valid, and then so based on the response coming from the destination, and then so it is ready for the data, then it is sending the data to the destination. Okay, so but in this handshake control signal method also, we in this asynchronous data transfer, so we have some problem that is called as timeout. Okay, So if the written handshake signal does not respond within a given time, suppose in this example, if the destination doesn't give acknowledgement that it has received the data. Suppose in this example, the destination unit is doesn't send the ready to receiving data signal to the source within a time. So then it will be, it means that particular data transfer session is out. Okay, so it will stop the data transfer or it can take some other action. Okay, so that is the problem. Means here in we have to specify. So within the time, if the destination is give the response, then it is okay. If not, the data transfer action will be terminated. Okay, and similarly we have the another thing. Okay, baud rate, data transfer rate in bits per second. Okay, so here we have to check those two baud rate also, the source baud rate and the universal baud rate. Sorry, destination baud rate. Okay. Okay, we have some disadvantage that is called as the time watch. Understand? And here we have the some transmitters, receiver and transmitter, and the port number of these transmitters are 8250 and the 8251. Okay, universal asynchronous receiver transmitter, universal synchronous or asynchronous receiver transmitter. Okay, so these are the some interfaces for the peripheral devices. Okay, so we will see something. See in this example. Sorry. Okay, so this is an example for the UART, Universal Asynchronous Receiver Transmitter. Suppose see here, we have the some internal bus system. Okay, suppose, yes, this is the internal bus. Okay, next one. So this is the some source rows and this is the destination. Okay, here we have the some bus buffers and come to the here we have some registers in the destination side. Okay, destination or the source. Okay, so what are those? Transmitter register. This transmitter register is accepts data from the data bus. Okay, and transfer that data to a shift register. Okay, data is transferred from the this internal bus and the data is transferred to the shift register. Okay, from the shift register it is transferred to the destination. And receiver register. Okay, this is the receiver register. Okay, so this receiver register first receives the information from the source or the destination. Okay, first that is stored in the shift register, and from the shift register it is received to the receiver register, and from this receiver register it is transferred to the internal bus. Okay, already I told you there is some IO commands. Okay, data input command, data output command. Okay, see, and a status command. So here status register. Okay, from either source or destination, first it receives the clock control. Okay, so receiver control and control and the call. Okay, if it is ready, then that particular status, the source is ready, that status is transferred to the internal bus. Okay, and similarly we have the control register. Okay, so why we require control register means suppose the baud rate for the two units will be different sometimes. Okay, so and number of bits for each character. Suppose one is follow the ASCII code and another one is follow the Unicode, then the number of bits required for the character is different. Okay, so and also for the information, so we have the not only we have the data. Okay, we have the start bit and the stop bit also. Okay, this is the start bit representation, this is the stop bit information, and it is the original data. Okay, so everything is stored in the control register. Okay, everything is stored in the control register. Okay, so that control register data, transmitter clock, this is the control log clock. And so when the status is okay, control is okay, then the control register is activated by using the internal bus data. Now see, here we have the CS, okay, chip select. Okay, suppose now we have the two chips, okay, 0 and the 1. Okay, suppose we want to do interact with the chip 1. Okay, so then when the chip is equal to 0, okay, so then there is no uh, then there is no actions will be performed. Okay, so when the chip is 1, okay, suppose we are selecting the required chip, so means that the chip is enabled. Okay, so when it is enabled, okay, when it is enabled, what happened? Okay, the chip is one, the required chip is enabled, means the source from where the data is received and transmitted. So that is the selected. Then, so we are go for the this RS. Okay, so here RS means register selected. So which register we have to select? Okay, in the source unit which register, in the destination which register. Okay, we have to select. Okay, so that is the RS. What is the operation? So we have the two operations. One is the write operation and the read operation. If RS equal to 0 means so register selected. So, okay, that is the source. Source is the source, from the source register data is written. Okay, if 0 means source. From the source register data is read. 1 means, so here 1 means from the destination data will be written. Okay, so 1 here from the destination data can be read. Okay, and here, so these the combination of chip select and the register status RS. So these both will be give the, so which register will be activated. Okay, so here write transmitter register, and here the RS is okay, RS is equal to 0. Okay, register status equal to 0 means, and we have the write operation. So means simply data is transferred. Okay, so when we have the RS is 1, then control register will be activated. Okay, so based on these commands, particular register is activated and they will perform the particular action operations. Okay, students. Okay, so this is the topic, and we have the another topic that is the modes of transfer. Okay, in the next video, I will teach that one. Okay, students, thank you.